welcome to another exclusive video. My friends, welcome. In this video we're gonna go over what is maybe considered to be the bread and butter of conceptual calculus. Notice before what we did was we went over problems that were derivatives with square roots, and those are challenging algebraically. Now we're going to hit on things that are conceptually, and we try to split the two up so now we can try to bring them together. So in case you didn't know, I took this little diagram that I found online. Anytime you want to find when something is increasing or decreasing, you just have to know when it has positive slope. So notice right here, it's a positive line, right? Positive slope means it's increasing, that's all. Notice right here, this does not have any slope. There's no rise over run. That's why it's constant, or in other words, zero. And well, right here, this says positive or negative slope. Well, it has positive, so that's why it's increasing. And notice this red line here, well, this red line has negative slope, so that's what's considered decreasing. And that's really it. It's a big idea in calculus, but that's really all there is to it. So let's look over here to the graph to the right, and let's try to find out when it's increasing or decreasing. Okay, well, the first thing we want to ask ourselves is, when do we have zero slope, right? Let's figure that out first. Well, we have zero slope at our bumps, right? Because we have this horizontal derivative tangent line. So we know here it's zero. So it doesn't increase or decrease on those points there, right? Well, what about to the left of the zero? What about right over here? Like right here, this right here, is this positive or negative slope? Well, anywhere you draw these little instant slopes, this is increasing. That's increasing. Let me change the color a bit. Let's go over here. Well, what about here? Does this have positive or negative slope? Is it increasing or decreasing? Well, if you look right here, if you just draw a little line like that, you'll notice this is negative slope. So this would, in that little interval there, it would be decreasing. Well, what about to the right over here, increasing or decreasing? Well, it should be increasing. It has positive slope. So if you wanted to write this, well, let's just assume this is like 1.5, and let's assume this is 1, 2, 3, 4. Okay, well, from negative infinity, right, all the way down here, all the way till 1.5, are we increasing or decreasing? Well, we're increasing. Is there anywhere else that we're increasing on? Well, we talked about it right over here. This is increasing as well. So from 4 to infinity, we're also increasing. And when are we decreasing? Well, in between these 2 points, right? Right here, in between these two. So we could say that from 1.5 to 4, we are decreasing. Okay, and that's kind of a quick introduction to increasing or decreasing, and being able to determine that. We were able to look at this graph and find out when it's increasing or decreasing. So let's take a look here, because really in this video, what we really want to hand on is, how do we sketch derivative graphs? Well, it has to do with increasing or decreasing, because I want you to think for a moment. Well, what is the derivative? Well, the derivative tells us our instant slope, right? So let's ask ourselves this question before we even begin here. Thinking about that, well, when on this graph do you have this graph right here? Do you have zero slope? Well, I have zero slope right there. So I should mark in 0 here. Okay, to the left, right over here, is it positive or negative slope? Oops, I kind of drew that tangent line kind of bad. Is it positive or negative slope? Well, my friends, it looks to me like this has negative slope, right? If you graph this in any way that you like, right here, right, this line right there, this does in fact have negative slope. So I bet you from the left it's negative, so this is decreasing. Right over here it's decreasing. So if we're decreasing, right, and this is our derivative graph, so this is, let's say, x, and this is y. Remember, the derivative is going to tell me my slope, so let's write y prime. So since here it's 0, well, right up here, like 1, 2, 3, 4, right? These numbers, that is positive slope. And the numbers down below means negative slope. So since we are decreasing, since we have negative slope, where would this graph be at, right? Is it going to come here to here? Like start up here and come down to here? Well, that wouldn't make sense because this is positive slope values. So we don't want to graph from there. Well, what would be the next alternative? Well, we know it has to get to 0, so we know it has to do this, right? This is here, it's decreasing, it's negative slope out, -1, -2, these are negative slope values, and it's going closer to 0. So that's where we started. Well, as we go to the right now, this function right here, from the right, is it positive or negative? Well, it has positive slope, and since it has positive slope, that's going to tell me that this is increasing. So since it has positive slope, as we get away from our slope of 0, we are positive, we are increasing, so it's just positive, such like that. And that's how we can sketch derivative graphs. And if you think about it, here's our equation, y is equal to 2x, okay, y is equal to x squared. Take the derivative, and we're gonna get, we'll bring the 2 down, so we get 2x, subtract 1, so 2x to the 1, so we just get 2x. Well, does this make sense? Well, at 0, if I plug in 0, 2 times 0 is 0. That makes sense. Well, let's plug in a 1, like a positive 1. If I plug in 1, what's 2 times 1? Well, that's 2. It's positive, which makes sense that it would be up here. And maybe we'll label this 2. Okay, if I do 2 times -1, well, that's -2. So right over here, it's -2. Okay, which should make sense. Okay, even if we took the derivative and just graphed it, it would make sense either way. Okay, so let's take a look at this graph here. Let me just zoom in. Here is the graph of f of x. Find f prime of x. So what we want to do is we want to sketch the derivative of this graph. But most importantly, if we just think about increasing or decreasing intervals, that's what's going to help us do this. So if you look over here, where do we have 0 slopes? Right, where is it 0? Well, whenever we have a bump, okay, we have this horizontal line 0. So you know here it's 0. So it looks to be like about 1.2, right over here, like 1.2 and 2, 3, and like 4-ish, right? So let me just approximate it right here, and 2, 3, 4, and 4-ish. Okay, so that's where my 2 locations on this graph is 0. There it is, these 2 functions right there. So now we just ask ourselves very casually, to the left of the first 0, is this positive or negative slope? Well, it looks to me like positive slope. Now let me just label this as x, y. This is, remember, this over here to the right is derivative graphs. This is telling us positive or negative slope. So since this has positive slope, that means it should be positive. It should have positive y derivative slope. So positive, increasing, and it's going down to 0. Does that make sense? This is increasing, and so it should be positive heading to 0, right? Heading closer to 0. Well, what about right here? Well, if you just kind of graph this like such, this is decreasing. It has negative slope. Since it has negative slope, it should be down over here like such. Okay, it's decreasing, and then it's here it's 0. So notice how we're completely decreasing, but it goes from 0 to 0, so it has to touch back. Well, what's the only way for me to be negative? The negative slope values down over here, but still come back? Well, the only way to do that is just to literally come back like such. And then over to the right, are we increasing or decreasing? Does it have positive or negative slope? Well, positive slope. So our graph will look something like such. Okay. And you'll kind of notice something interesting. This had 2 bumps, and when you take the derivative, you now have 1 bump, right? Now, the graph to the left, I know was something like x to the 3rd. So when you would take the derivative of this, you'd get 3x squared. So notice how you get x to the 3rd, and now you're down to quadratic, which would kind of make sense here. All right, let's go take a look at a few more here, and let's see if we can continue to make some good observations. Okay, here we go. Let's take a look at this one here. So let's determine the derivative graph, right? So this is y prime or f prime of x. This is x. This is just x, and this is y. Okay. Well, first thing I want to do is find when there is a slope of 0. I know there's a slope of 0 here, here, and here. At 1 and 4. And about 7-ish, so 1, 4, 5, 6, so around 7-ish, somewhere over here. Okay, so I'm just estimating, not a big deal. So to the left of this, is this increasing or decreasing? Does it have positive or negative slope? Well, right here it has positive slope, so this is increasing. So we know our graph should come in from here, right? It should have positive y prime values, positive slope values heading towards 0. Over here, this is decreasing. It has negative slope to 0, right? So it goes from 0, decreasing, and then it gets back to 0. So we know we're decreasing, and it gets back to 0. And over here it's, well, this is increasing, and then over here it's decreasing. Okay, so notice how this is going to go decreasing, but it has to come back, because now as it came back to 0, now it's going to increase. So we're going to increase, be in the positive region, but then it's going to go back to 0 and then decrease. So back to 0 and then decrease. And there it is. There is our f prime graph. And that's it. So here's another one. Sketch a possible graph of the derivative based on the graph of the function. So we look over here. Here is when it's 0 at 2. So I'll mark 2. Over here to the left, does this have positive or negative y values? Well, that looks like it has positive y values, right? So since this has positive y values, well, that means it's going to be positive here heading to here. And then to the left, it has negative y values, right? It's decreasing. So it's just going to go down over here like such. And boom, there it is. Nothing else to be done.